Now you do. The ACT? You have to take the ACT. 17, I think. Yeah. Yeah, I was gonna say 11 or 12 is the lowest. But you do have to take it like in March or April. There will be a day where y'all take the plan test or the explorer or something. Okay, then maybe it's the plan. I don't know. Ninth grade take something, 10th grade take something. The juniors all have to take the ACT, and the seniors that haven't made a 17 have to. All right, we're looking at uniform motion problems where the distances add up to a certain number. The distance of the first person plus the distance of the second person equals some random number, or the distance the first time plus the distance the second time equals a k. All right, what are you talking about? If I'm talking, you should not be unless you're asking a question to me. It's disrespectful to me when you're talking while I'm talking. All right, so you can have 3 different diagrams for these. You can have 2 people that are meeting each other. Like someone starts in Shreveport and someone starts in Jackson, and they're driving towards Monroe. Does that make sense? You can have someone going from Ruston to West Monroe, and then the next person going from West Monroe to Monroe. It doesn't matter. You can also have starting in the same place and going in opposite directions. Starting here and going here, and then the other person starting here and going there. Coming together. Mm-hmm. Mm-hmm. Like if you ride a bike for a little bit and then you get off your bike because it breaks and you have to walk the rest of the way. All 3 of these, the distance of the first time plus the distance of the second time is the total distance. It's just some number, whatever they add up to be. Does that make sense? Okay. So here's an example. Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on a horse. Whatever that is. No, doesn't really matter. He walked it 3 miles and he rode it 9 miles per hour. Total time was 8 hours. How long did he walk? First thing you should do is to set up a diagram. He started somewhere. And then what did he do? He went and then he stopped, right? And this was when he was doing what? So he was walking. This is the distance that he was walking. Does that make sense? And then what happened the rest of the way? He rode his caisson, the distance that he was riding. Does that make sense? What do we know about this total distance? It tells us that total distance was 60 miles. Does that make sense? So the distance walking plus the distance that he was riding equals what? Does that make sense? Let's see how that works so far. What do we know about distance? What does it equal? Uh-huh. You agree? D equals RT. When he was walking, we don't know his distance. What was his rate when he was walking? Okay, do we know the time that he was walking? That's how long is walking. Time of walking. We don't know. Does that make sense? When he was riding, do we know his distance? It was just DC. What was his rate? And what is his time? They add up to 8, right? So if he walked for 4 hours, how long would he have ridden? 4 hours. If he walked for 4, 8 minus 4 gives you 4. Does that make sense? No, I just picked a number. If he walked for an hour, then he rode for 7 hours. So 8 minus 1 is 7. Any questions on these so far? Mm-mm. So instead of DW, what could I put in? RT, rate of walking, time of walking, right? D equals RT. And then instead of this D, what should I put in? Rate, time. Not yet. I'm just writing my equation. Make sense? Yeah, I won't be able to follow your work probably, so I won't be able to tell you where you went wrong. But yeah, if you want to do it a different way, that's fine. What do we know for the RW? Look over here. It's 3. What did we put for the TW? TW. What did we put for the RC? We said 9. And then for TC, what did we say? Does that make sense? We just took the information from our chart and plugged it into our equation. See how that works? Two different equations? What do you mean? Okay, what do we know about D? D equals RT. So instead of D, RT. Because distance equals rate times time. Those are the kind of problems we've been doing. Distance equals rate times time. So the distance that he walked is the rate that he walked times the time that he walked, plus the distance that he rode, the rate that he rode plus the time that he rode. And we know that all of that equals 60. And then we just plugged in what each of those mean. He rode at 3 miles per hour and he walked at 3 miles per hour and he rode at 9 miles per hour. And then we just filled in what we knew about the times. Does that make sense? I haven't yet. Just distance equals RT. No. Rate did not equal time. Distance equals rate times time. RT equals RT. Because the distances were the same. But on these, distance still equals RT, but the two distances aren't the same. They add up to 60. So you have to add the two distances. Yes. Yes. That's what they're wanting you to learn how to do. Any other questions getting to here? Okay, so you're going to distribute here like that. So you get negative 6 TW plus 72 equals 60. Negative 6 TW equals negative 12. And so what would yeah, it would be 2. So if he walked for 2 hours, how long did he ride? This is 2 and this is 6. Does that make sense? Y'all see how that works? It says, how long did he walk? He walked 2 hours. If it said, how far did he walk? How far did he walk? 6. If you are unsure what it's asking, say he walked for 2 hours for a total of 6 miles. Does that make sense? Like give both if you are unsure about which one it's asking for. Rate times time is distance. Any other questions? Do y'all understand the difference between these compared to what we were doing? On these, are the distances the same? On the other ones, they were. Every time the distances had been the same. Does that make sense? And these, they're being added together to get to a number. Yeah. I'm just using substitution on this one. You just substitute in. Because the rate times time doesn't necessarily equal the rate times time. Because the distances are being added to get 60 on this particular problem. Look at another example. Edward Longshanks and Queen Eleanor were 54 miles apart at dawn. So what does the picture look like? Okay, it's going to be 54 all the way across. Edward's on one, and the Queen is on the other. Does that make sense? At dawn, Edward began the journey. No, at 8, Edward began the journey at 3 miles per hour, and then 2 hours later, the Queen set out to meet him. So they're going towards each other. Does that make sense? I don't know who went further, but they're starting out away from each other and they're coming together. Does that make sense? So what is this part right here? It's the distance of Edward, and this distance is the distance of the Queen. What do we know about their distances? They equal 54. So the distance of Edward plus the distance of the Queen is 50. Make sense? All right, so now we want to fill in our little chart. What information do they tell us about Edward? Okay. He started at 8. When did they meet? So how long was that? Right? Does that make sense? What about the rate of the Queen? Did they tell us that? So we just have rate of the Queen. We don't know what it is. What about the time of the Queen? She started 2 hours later than Edward. So she started at 10, or they ended at the same time. So she was only 6 hours long. Either one. If you want to say 10, 11, 12, 1, 2, 3, 4, or if you just want to say she started 2 hours later and they stopped at the same time, she had 6 hours to go. Does that make sense? The time? He started at 8 and they met at 4. He stopped walking at 4 p.m. So from 8 to 4 is 8 hours. And then she started 2 hours later, so she started at 10 and they still stopped at 4. Any other questions on this part? I didn't fill in the distances because can we find the distance of Edward right now? Distance equals rate times time. What is his distance? Does that make sense? We still don't know the distance of the queen yet. But do you see how we know Edward's distance right now? So what is the distance of Edward? 24. And then the rate of the queen and the time of the queen equals 54. Does that make sense? Yes, we know the time of the queen is 6. Does that make sense? So can we solve for our RQ? So RQ would be, does that make sense? Okay. How fast did the queen travel? Is that the rate? How fast? So her rate was 5 miles per hour. So, hour. They won't always be miles per hour. Sometimes they're kilometers per hour. Y'all see how that works? K, T, H. Any other questions on this one? You're supposed to. I'm not going to mark off for it. KPM, kilometers per hour. KPH, kilometers per hour. Yeah, you could do that. At noon, Rocket Man whizzed off toward Rocket Land. An hour later, Moonfa whizzed off in the opposite direction at a speed of 200 kilometers per hour, kph, less than that of Rocket Man. If they were 11,800 kilometers apart at 5 p.m., how fast did each travel? What would our picture look like? They started at the same spot and they went opposite ways. Does that make sense? It's okay if your picture is not to scale. It could actually look like this, but it really doesn't matter. Does that make sense? You're just showing they went in opposite directions. What is the total distance? Do we know that? They were 11,800 miles apart whenever they stopped, or at the time that they said to stop at. Does that make sense? So this is the distance of Rocket Man, and this is the distance of Moonfa. So what would be the equation? Does that make sense? Y'all see how that works? Okay. Can we fill anything in for Rocket Man? He left at noon, and when did they stop? So his time was, okay, an hour later, Moonfafa, so that's 4, from noon to, wait, an hour late, from 1 to 5, 2, 3, 4, 5. The first one left at noon, and the next one left at 1. Does that make sense? Do they tell us the rate of either of them? Okay, so the rate of Rocket Man and the rate of Rocket Man minus 200. Do you agree? whatever Rocket Man was going, Moonfa was going slower. No, not necessarily. Their distance is added up to 11,800. Does that make sense? We know distance equals rate times time. So instead of distance of Rocket Man, I can say the rate of Rocket Man and the time of Rocket Man plus the rate of Moonfa and the time of Moonfa. Does that make sense? So do we know what rate of Rocket Man is? It's just RR. What is the time of Rocket Man? Do we know the rate of Moonfa? RR minus 200. And the time of Moonfa is 4. Y'all see how that works? Any questions on the R, this one? Here? Is that what you're talking about? RR minus 200? Because Moonfa whizzed off going 200 less than Rocket Man. So the 4? Oh, his time was 4. Any other questions so far? Okay, so we know 5 RR plus 4 RR minus 800 equals, does that make sense? So 9 RR 12,600. And then what would the rate of Rocket Man be? 1,400? I'm going to go with you on that. I didn't actually plug it in my calculator. That looks about right. Does that make sense? So that's how fast Rocket Man went. How fast did they both go? Because the rate of Moonfa was 200 less than Rocket Man's. So if Rocket Man's 1,400, 14 minus 200, 1,400 minus 200 is 1,200. It says how fast did they each travel. So you have to have one for both. So both of these would be your answer. Does that make sense? Now see how that works? Do we need to do another one? Anybody? It's a lot of work. I think that if you'll start by doing the picture and your diagram, it'll make it a lot easier. Eventually, you'll get to where you don't need the picture and or the diagram, but if you're having trouble with these, do both of them. Okay? Does that make sense? Like, hopefully, by Christmas, you won't need the diagram and the picture both. You'll be able to eliminate one of them. Does that make sense? I don't know. Some people might already be able to eliminate one of them or both of them. But if you're having trouble with these, do both of them to see if that'll help you figure it out. Any questions?